Diffusion, the international science radio show.
We have a bouncer on the doors of perception.
The good, the bad, the ugly.
It gets pretty exciting.
The myths, the truths.
Toxicology.
Astroseismology.
Magnetism. The dark side.
Genetically engineered potatoes.
Planetoid.
Planetoid.
I love that word.
Hello and welcome to Diffusion. Sit back and relax while we inject weird and wonderful science directly into your genes. I'm Ian Woolf. This week, from the Ghosts of Diffusion Past mini-disc archives, I present to you this edition from September 2005, 13 years ago, when the show was called Discovery, and when there were several contributors in the team. In this episode, the team inform you about Fizzy Icecream, music for airplane wings, and more news about chimpanzees than you can shake a stick at.
Welcome.
Stand and welcome.
Hello, good evening and welcome
To Discovery.
Discovery.
Listen to Discovery.
Discovery.
Sounds like a lot of fun.
Somewhere in space, this may all be happening right now.
Now, to the speeded up brain of a user, that sound lasts for 4 hours and sounds like this.
Discovery.
That's right, welcome to Discovery, the National Science Show. I'm Jacqui Pfeffer, and this week we'll be having a chat about Fizzy Icecream, changing the in-flight soundtrack, and we've got enough information on chimp DNA to poke a stick at. But first, let's head over to the news team.
The excitement is still fresh in the minds of the paleontologists who dug out a piece from the roots of our family tree. Sally McBreety and Nina Jablonski of the University of Connecticut were the first ever to find intact remains of the chimpanzee. This valuable discovery of fossilized teeth were made in a rather unexpected place and could have staggering implications for how we viewed our distant cousins. The specimens were found in East Africa, where humans were thought to have lived as well, and the reason they weren't found sooner, says Dr. McBreety, is that no one looked for them in those areas. This time capsule is an inspiration to paleontologists for further information about our past. Daniel Lieberman of Harvard University is certainly jolted, especially because he says that such a find raises the hope that we could uncover even older stuff. Meanwhile, you'll never look at chimps the same way again.
I just find it fascinating in that news story that the idea was that they hadn't found it before because no one had looked there. Like normally in science, isn't it sort of, well, you hadn't found it because it was a very, very difficult problem. This one is, we hadn't gone there. No one had dug up that bit of earth. Oh, well. That's one piece of chimp news we've got. We have other chimp news.
The genome of our closest living relative, the chimpanzee, has been revealed by an international consortium of scientists, according to this week's New Scientist. The chimp genome consists of 2.8 billion pairs of DNA letters, and although this information tells us a lot about chimps themselves, more importantly, a comparison with the human genome will teach us a great deal about ourselves. The major accomplishment is that we have a catalogue of the genetic differences between humans and chimps, says lead author Tajay Mickelson of the Broad Institute in Cambridge, Massachusetts. The new comparison shows incredible similarity between the genomes. The average number of protein-changing differences per gene is just 2. What's more, only a handful of genes present in humans are absent or partially deleted in chimps. With such extensive similarity between the genomes, one would expect a corresponding similarity in physical traits. And yet it is plainly obvious that this is not the case. The puzzle remains unsolved, as Ivan Eichler of the University of Washington admits. From this study, there's no silver bullet of what makes chimps chimps and humans humans. And so the real challenge now will be finding the changes that played a major role in the evolution of chimps and humans since the two lineages split 5 to 8 million years ago.
So the chimps, are they our closest relatives on the genetic tree? I mean, we're not descended from them, but are they the closest to us?
I think they are, actually. I mean, I know what you were saying before earlier that, it's so closely related, but we don't look anything like a chimp. If you look at humans and look at all the different variations in a human, we all still like we're all still humans, but you think of how many little genetic differences there are between even just the 5 of us in here tonight. But, you know, so you're going to expect that 2% difference between humans and chimps, and yet we still look completely different.
Yeah. So they're the closest thing to us, with we share most of the same DNA. On the other hand, humans and bananas share about 50% of the same DNA. So let's not get too carried away here. But the big question, I guess, I want to know is, does this mean that, like, you know how you can have, horses and donkeys? Is that right? The horses and donkeys can breed, and that makes a mule. Now, they're different, horses and donkeys. They're not the same thing. Does that mean that humans and chimps could breed? Because that's, there's an experiment out there waiting to happen, and someone's going to try.
I'm sure someone in America's already tried it.
They probably have, actually. I could think of a particular president that we could point to, but let's not even go there.
And in non-chimp news this week, New Scientist has reported that the next visitor to fly across the lunar landscape from Earth could well be the humble penguin. Engineers at US defence contractor Raytheon have proposed a new lunar explorer dubbed the Lunar Penguin. The robot does not actually resemble a flightless tuxedo-wearing bird, but actually is a squat, four-legged lander weighing about 100 kilograms and just under a metre tall. Designed to jump across the lunar landscape, the Lunar Penguin will be able to leap over a kilometre at a time. This form of locomotion would enable the robot to clear obstacles that would otherwise prove impassable, such as meteor craters. Similar craters have proved to be difficult for the Martian rover, which is propelled by wheels. The downside for this method is that getting around the lunar landscape would impose very large stresses upon onboard instrumentation. The device is to be built predominantly using off-the-shelf technology, such as the guidance system from the Tomahawk cruise missile. Project team leader Carleen Siebold says the Lunar Penguin could be ready to launch as soon as 2009.
See, I was really excited about this story because I thought they were serious. I thought we were going to actually have a penguin.
Well, the problem is penguins can't even fly on Earth.
Yeah, well, but give them a rocket booster, and they'll get there.
Anything will fly with a rocket.
Anything will fly with. Mythbusters have told us that. But I mean, we've had a chimpanzee in space. We've had plants in space, fish in space, probably, or something.
Dogs.
And I thought dogs in space. I thought pigs in space. I thought we were going to have penguins, but no, this is just a big bouncy thing. This is basically Magic Roundabout. This is Zebedee on the moon, right? You remember anyone watch Magic Roundabout as a kid, or is it just me? I'm just talking to myself here at this point. Forget it. Those of you listening out there, if you remember Magic Roundabout, you're with me on this one, aren't you? Yes, indeed. This has been your animal-themed news this week on Discovery.
Now you're listening to Discovery, the National Science Program, and just when you thought no one could make ice cream any better, along comes someone with a revolutionary new design. Ice cream has been around for centuries, and the modern methods for making it have remained virtually unchanged since the early 20th century. But the good people at MIT have now developed a way to get some fizz into our ice cream experience. So take it away, Matt Clarke.
The history of science is full of notable quotes shouted in triumph by people at the moment of discovery. There's Archimedes, who screamed, "Eureka! I've got it!" Insert Greek accent there. After discovering, while taking a bath, that an object placed in water will displace an amount of water equal to its own volume. Interestingly, about 3 seconds later, he also became the world's first recorded streaker, when he leapt from his bath and ran through the streets in excitement over his discovery. And of course we have Alexander Graham Bell in 1876 with the famous but unimaginative first phone call to his assistant Watson. "Mr. Watson, come here, I want to see you." But recent times have seen another great quote added to the pages of scientific history, as MIT graduate student Teresa Baker ran out of her lab screaming, "I made ice cream! Come down and eat it!" You see, Baker, working out of the Cryogenics Engineering Laboratory in Cambridge, has been making ice cream in a rather unconventional manner. Instead of the traditional churning method used for centuries, Baker has employed a system of liquid carbon dioxide, bulky stainless steel cylinders, heat exchangers, and of course vanilla ice cream mix. But when she finally got the technique right, what came out the other end of the very large machine was a very special kind of ice cream. It was actually fizzy ice cream. Well, according to Bob Roberts, the Associate Professor of Food Science at Pennsylvania State University, it's not actually called ice cream. Just like peace protests can't actually be called peaceful most of the time. See, the definition of ice cream, according to the government's Code of Federal Regulations, states that ice cream is a food produced by freezing while stirring a pasteurised mixed. And since MIT's Fizzy ice cream isn't actually stirred, it would actually be classified as ice confection in Australia and America. But all that aside, Baker and the MIT team have been speaking with the big boys of ice cream about getting this exciting discovery to a supermarket cabinet freezer near you. So how do they make it? Well, I'm glad you asked. Well, first I'll start with how they make traditional ice cream, how they've been making it for centuries. Ever since this, they've been using this way ever since 1920. And what they do is they get the liquid ice cream mix, they throw it through a chilled pipe, and as it hits the pipe that's around about 30 degrees Fahrenheit, they get scrapers that go around the outside of the pipe, they get the ice crystals off and mix them into a liquid. After they've done that, they beat massive beaters beat air into these ice crystals. They make it fluffier, and it takes about 30 seconds, and what comes out at the end is what we now know as ice cream. But Baker's method is a lot different and a lot easier than that. The Fizzy ice cream is made with 2 big flasks, one on top of the other, and a whole lot of tubes. And one of these tubes contains liquid carbon dioxide, and the other one is filled with the ice cream mix, which they basically made up of milk, cream, sugar, and non-fat milk solids, and a whole lot of chemicals, as most ice cream is. Now, the tubes flow through like an esky that's filled with ice water, and through a whole lot of valves and gauges before they both empty into the flask, which is held under very high pressure. Now, the liquid carbon dioxide and the ice cream mix together inside this flask before being forced through a nozzle into the low pressure chamber below. When they're forced through this nozzle into the low pressure chamber, the carbon dioxide transforms into gas instantly and turns the liquid ice cream mix into ice crystals, which are pretty much like snow. In fact, they're only around about 30 microns across, which is smaller than the diameter of a human hair. I think that's even smaller than a snowflake. But according to the taste testers, it does feel very much like snow, a new fallen snow apparently, when you're putting it on your tongue. And that's actually where the fizz comes from. It comes from when the ice cream hits your tongue and starts to melt, because what happens then is it releases the carbon dioxide gas which has been trapped in these ice crystals, and creates a fizzy sensation, just like you get from a soft drink. And if you eat it too fast, not only do you get an ice cream headache, but you also get bubbles up your nose, just like if you were drinking a soft drink too fast. So here's to Teresa Baker and her team at the Michigan Institute for Technology, keeping right up there at the melting edge of ice cream technology.
And that was Matt Clarke with the latest in ice cream technology. You're listening to Discovery. That was I Got Plenty of Nothing by Spearhead and Ernst Ranglin. Now, Chris, you've got an interesting story this week about aeroplanes and keeping them up with music, haven't you?
I do indeed. This is a story that came out of a thing called the Fresh Science Forum, which is part of National Science Week, which you might remember was kicking around a couple of weeks ago now. And the Fresh Science Forum is where a bunch of guys down in Melbourne gather together, a lot of young, up-and-coming, talented scientists who are doing really interesting work who no one's ever heard of before. And they go, this deserves some attention. Come on down to Melbourne. We'll give you some media training. We'll put you in front of the microphones. Tell us your story. So if you're out there and you're an up-and-coming scientist, get in touch with the Fresh Science people and go out there and spread the word. But anyway, this year in National Science Week, Fresh Science featured the work of a guy called Ian Salmon. Now, Ian's an aeronautical engineer. He's been doing a bit of work on stalling. Not as in sort of buying time, as in planes taking off or coming into land and then suddenly going, oops, don't have any lift anymore, and crashing into the ground. Now, to understand this, you kind of need to know a bit about aeronautical engineering. Fortunately, we happen to have one here in the studio with us. One of the new Discovery team members, Adam, is in fact an aeronautical engineer. What are the chances? Adam, hi.
Hello, Chris.
So, stalling. Tell us about stalling. What's it about? What does it mean?
Okay, first of all, stalling with an aircraft is completely different to stalling with a car.
Okay, stalling with a car, your engine stops and you roll to a halt.
And it's not
Stalling
a big
with
deal.
a plane,
It's bad.
how bad?
Well, it's very bad. As we should all realise, aircraft need air flowing over the wings to produce lift. That's how they fly. Stalling with an aircraft means that the air is no longer flowing over the wing properly and it's no longer producing lift.
So the very thing that's keeping the plane in the air has stopped keeping the plane in the air.
Exactly.
Which means it's going to fall.
It's pretty bad.
Right.
So your only option is to get up more speed, and then the air will flow over the wing properly, and you can keep flying.
Okay, now does this mean that as the plane is plummeting towards the ground, it'll speed up and therefore not be stalling anymore?
That's called a stall recovery.
Hey! I could fly a plane, no problem.
That's the only way out of a stall, is to
Right.
put your nose down and get some speed up.
Right.
So
The problem is that this tends to happen when planes are just taken off or landing. Like that's when it's...
Exactly. It also tends
And
to
so you're not
happen-
far from the ground.
Yes, also when aircraft have a very high angle of attack, because that's
Mhm.
when they're producing the most lift,
Mhm.
the air is working the hardest.
Mhm.
And that, of course, happens at low speed, which is where the aircraft needs to produce a lot of lift,
Mhm.
so taking off and landing. So taking off and landing, you're flying at low speed, which means you don't have a lot of energy to keep you up. You're flying at a high angle of attack to produce your lift, which is a perfect condition for stalling to occur.
Even a 747 falling from a small height is still going to make a real mess. So this is a problem. Now, getting back to this Ian Salmon guy, because he's not the first person to think of lift, but he has come up with a pretty clever idea to get around the problem. What he's done is he's building speakers, as in, stereo-style speakers, big bloody things, into the wings of the planes. Now, what he's noticed is that if you have a plane wing and you blast sound at it, then the air goes over the wing a bit more smoothly, something along those lines. And so basically you can get rid of the stall that way. But dragging along a bloody great stereo system in front of the plane, just not terribly practical. He had the brainwave just build the speaker into the wing. Very clever.
Very clever
How does
indeed.
this work, Adam?
Well, how it works is, although, as I said before, you have air flowing over the wing, in between the air that's flowing over the wing and the wing itself, you have a very, very thin layer of air that is actually moving very slowly, called a boundary layer. And this boundary layer is very highly turbulent, and what it does is it acts like glue, and it sticks the air that's flowing over the wing to the wing. Stall is when the air that's flowing over the wing is no longer stuck to the wing, it's become unstuck. So what this guy is doing is he would be using speakers to increase the effectiveness, the stickiness of that boundary layer, so it sticks the air to the wing at higher angles of attack. And this would enable the plane to fly steeper and slower without stalling.
Well, the big question is, does this actually work? I mean, it's a nice idea. According to the information that we got from the Fresh Science people, this particular invention, this particular bit of technology that Ian Salmon's come up with, allows them to get in the order of 20% more lift at the same speed. Now, does that then translate to, well, you could go up at sort of 20% greater angles, you could...
Yeah. It would mean 20% greater angle, but it might not be too good for your long-term cruise, because there you're worried about your drag.
Right.
And 20% more lift means significantly more drag as well.
Right.
So this may not be too good for crossing the Pacific and going to America or heading over to
Well,
England.
maybe you could just turn them off.
Exactly.
When
But
you're taking
certainly
off and landing.
Certainly
yeah.
in taking off and landing, which
Yeah.
are by far the most dangerous parts of flight.
Plus, it would also mean that if you get 20% more lift, couldn't you have 20% smaller wings?
Indeed you could.
Which mean probably not a good idea for a jumbo, because you need the wings to store the fuel.
Exactly.
Right? But you could have smaller planes, for
Yes.
example.
And you could fit this onto light aircraft like a small Cessna, and it could stay in the air for a little bit longer.
Or one of the examples that's talked about in this article is unmanned aerial vehicles, or UAVs, tiny little planes. And some problem with a small plane that you're just not getting enough lift from these tiny little wings.
Exactly. These unmanned aerial vehicles, currently they're being designed to launch from sonobuoy launchers from other aircraft, or even fired out of guns. So they're incredibly small wings on these things.
Well, word up to Ian Salmon, who is a aircraft development engineer with Qantas. He's one of the Fresh Science people at National Science Week for 2005.
Unfortunately, that's all we had time for on Discovery this week. If you'd like any information of any of the features that we presented this week, you can contact us on
science@diffusionradio.com. That's science@diffusionradio.com.
In the studios this week, we had Adam Richardson, Peter Robbins, Michael Sun, and then, of course, Discovery was produced by Chris Stewart this week, who you heard earlier, in the studios of 2SER Sydney. We're also broadcast nationally via the Community Radio Network. I'm Jacqui Pfeffer, and I hope to see you all next week for our next edition of Discovery.
Science is fun. It helps you to learn, to know, and to appreciate. When you study science, you may go on field trips. You discover the marvelous interrelationships between all living things. You learn to read the history of the Earth as it is written in rocks and fossils. You find out what makes things tick, everything from a molecule to a living organism. In the study of science is found the most useful and satisfying knowledge of man. Knowledge of his physical world, its past, its present, and its future. And in your moments of relaxation, now and in the years to come, you will find the study of science leading you into fascinating pursuits. Photography, collecting. Why study science? Study science because you will find in the study of science a richer, more rewarding life.